So our question on LPP is: a firm produces products X and Y and sells them at a profit of rupees 2 and 3 each. Okay, so if I'm writing the problem along with reading it. If it sells, let's say the first product is X1 and second product is X2, that is number of the products is X1 and X2. Then it earns a profit of rupees 2 from product 1 and a profit of rupees 3 from product 2. So this means 2x1 plus 3x2. When the company will sell these products, this is the profit that it will get. Next is, each product is processed on machines 1 and 2. Product A requires 1 minute on first machine and 2 minutes on second machine, whereas product B requires 1 minute on each of the machines. Machine 1 is not available for more than 6 hours. See, maximum it is available for 6 hours 40 minutes, that is 400 minutes. And product X requires 1 minute on first machine and B requires 1 minute, that is X1 plus X2. This is the requirement. This has to be less than or equal to 400. This is the number of products. So both products when added, they cannot exceed this time limit, that is on the first machine. And second one is 2. See, the second says 2 minutes on the second machine. So this will be 2x1 plus x2 because it requires 1 minute only. Okay, so x2, this is not available for more than 6 hours 40 minutes. 6 hours 40 minutes per day. That is, no, second one is not, machine is available for 10 hours. So 10 means 600. So these are our constraints, and obviously since this is number of the products, so this has to be greater than or equal to 0. It cannot be a negative number. We have to solve this by Simplex method for maximizing this. Clear? This is your objective function which you have to maximize. Again I am telling you, this is the number of product first product. This is number of second product. Okay, so the company gets a profit of rupees 2 from this and 3 from this. So total profit will be this 2x1 plus 3x2. This we have to maximize, and it says that the first machine is available for only 400 minutes. And if the number of products is x1 and x2 for first and second, which we have taken, then this plus this cannot be greater than 400. It has to be less than or equal to 400. And for the second machine, this requires 2 minutes, first product, and second product requires 1 minute. So 2 into x1 plus x2 has to be less than or equal to 600. x1, x2 is greater than or equal to 0. So we have made the mathematical model of this problem, of this linear programming problem. Now, you know what we'll do? We'll have to convert it to standard form. Not convert, we have to transform it to standard form. Let's do it. How we convert to standard form? We'll get rid of this inequality. How? By putting slack variables, because this is less than or equal to. So what we'll have? This was x1 plus x2. So we'll have x1 plus x2 plus, let's have s1 as slack variable, and for here it will be s2. So 0 into s2 equal to 400, and here it is 2x1 x2. So this is 2x1 plus x2 plus 0 into s1 plus s2 equal to 600. Okay, this is, so s1 s2 is also greater than 0, and here we will have 0 s1 plus 0 s2. So our problem is now in standard form. Now we will start solving it. Okay, so what we'll do, let's write it somewhere in the corner so that we get a space for. So I've written the problem in this corner. What we'll do, we'll construct the table. The first column is CB and the second is basis. Now, you know, we have 4 variables, that is n is 4 and number of constraints is 2. Therefore, n minus m, that is 2. We'll have 2 basic variables and 2 non-basic variables. So, as I told you, we'll have s1 and s2 as basic variables. So, we'll write basic variables and the coefficients of basic variable in the objective function. Obviously, it is 0, 0, 0, 0. Then we'll write Cj. What is Cj? The coefficients of these x1, x2, x1, x2, s1, s2. Coefficient in the objective function, that is 2, 3, 0, 0. And then here we'll have b. B is what? 400 and 600. 400, 600. Okay. So first constant is x1 plus x2, that is 1 1 1 0. See, 1 1 1 0. Second is 2 1 0 1. So we have constructed our table for simplex method, for solving this LPP by simplex method. Then next step, what we do? We calculate Zj, which is this into this. So 0 into 1 plus 0 into 2. So this will be 0. Because this is 0, again here we'll have 0 0 0. Okay. And then we'll get capital Cj, that is Zj, see, Cj minus Zj. So 2 minus 0, this is 2. 3 minus 0, this is 3. This is 0. This is 0. So this is 2 3 0 0. Now we must have all our Cj less than equal to 0 for this to be an optimal solution, but this is greater than 0. So the greatest value of Cj, that will be our key column. So this is our key column. This makes our x2 as the incoming variable, that is this will now enter this, and one variable from this column will leave it, that will be outgoing. Which one will leave? What we do? We divide b by the elements in the key column. So this is 400 by 1, its theta will be 400. This is 600 by 1, 600. So what we take? We take the least positive ratio. This is 400 is the least positive ratio. So this will be our key row. So this is key column, this is key row. This will be key element. This is the outgoing variable and this is the incoming variable. Because it is 1, we don't need to normalize it. How we normalize? If this was 2, then we would have divided throughout by 2. So since it is 1, we don't have to do anything. So first step is over. What we do? We change the variables. Now S1 is outgoing variable. It is now 0. So now what we do? We put, we bring x2 here. And along with x2, what is its coefficient here? It is 3. We'll put 3. Okay. Now let's put this. So we used to do two things. First is normalizing this, that is dividing it by whatever the value of the key element is. Since it is 1, we don't need to do anything. The second thing is we make all the elements other than this of the key column 0. So how can we do that? We can do that by putting, if this is R2, we will do elementary transformation R2 minus R1. See, 1 minus 1 will be 0. So R2 minus R1 will be 2 minus 1, that is 1. 1 minus 1, 0. 0 minus 1, minus 1. 1 minus 0, this 600 minus 400. So that will be 200. Okay. So we have found this. Now let's see what is Zj. This will be 3 into 1, 0 plus 0 into 1. So this is 3. 3 into 1 plus 0 into 0. So again 3. This is 3 into 1, 0 into minus 1. That is 3. Okay. And this is 3 into 0, 0, 0. Okay. Then Cj will be 2 minus 3. That is minus 1. 3 minus 3, 0. 0 minus 3. 0 minus 0. So now all Cj is less than or equal to 0. This means this solution is, the first one was initial basic feasible solution. That was not optimal. Why? Because Cj, at least one Cj was greater than 0. Now here all are either less than 0 or equal to 0. So this is our optimal solution. Optimal solution means our x2 is equal to 400. So x2 is equal to 400 and x1 is 0. See, x1 is still here. So x1 is 0. So we will have our optimal solution, that is our z objective function or the profit will be maximized when x1 is 0 and x2 is 400. That is, we produce 400 numbers of the product y, the second product, using these machines, and we'll get maximum profit. And that profit will be x1, that is 0 into 2 plus x2 400 into 3. So this is rupees 1200. Our profit will be this, which is maximum. Okay. So we have solved this problem using simplex method.